Hello, and welcome to another episode of Fresh Natural Live. You guys are catching me in the middle of getting ready, but I'm going to share this screen and unshare it real quick. Tonight, I want to talk about an interesting topic as it relates to mitochondrial health and COVID-19. Now, this is somewhat of a technical discussion, but I'm going to try to break it down because mitochondria are very important organelles in our cells, and it has a very important role in the overall health. In fact, I will probably do, not probably, but I plan to do a series of discussions and from the perspective of mitochondria as it relates to heart failure, as it relates to diabetes, especially insulin resistance, type 2 diabetes. But tonight I'm going to talk about mitochondrial health and COVID-19. As we know, we have the flu season coming up. And so what does it mean to have healthy mitochondria? And what are some simple ways to improve your overall mitochondrial health? So hello, everyone. I hope you had a great weekend. I hope your Monday's gone well so far. Get ready for a great show tonight, as I think they're all great. But we're going to learn about mitochondria as it relates to physical fitness. We're also going to talk a little bit about food. We're going to review some information that I discussed before, and I look forward to hearing your comments and your questions, so stay tuned. All right. Hello again. Hello again. I just want to comment. You may have noticed I've been a little bit quiet on the channel lately. We've been working on some things behind the scenes. First and foremost, I'm working on the next webinar, which will be November 6th. I will be sending out the link to that very, very soon, probably as early as tomorrow. I didn't have it ready for tonight's show. I'll come on and do probably a special 2-3 minute talk and share that webinar. We'll be talking about insulin resistance and type 2 diabetes. I'll also be answering your COVID-19 questions. There will only be one webinar, and the seats will be limited. So sign up as soon as you can, as soon as we get that link out, which will likely be tomorrow. And so I see my friend and colleague, Dr. Ford Atkins, is on. Hello, Dr. Atkins. How are you doing?
Good, doing fine today. How are you?
Just fine, just fine. So just getting on with the group. We're going to talk about mitochondrial health and COVID-19. I'm going to focus on exercise and effects of exercise on mitochondrial health. And then I'm going to talk a little bit about food. So we're going to bring these two topics together, fitness and food. And essentially put together some of the nuances of the fitness and food factor. So without further ado, I want to say hello to Catherine Welch, Deborah Payne, JW, Miss Johnson. Hello, thanks for coming on so early. So what is this whole issue with mitochondrial health and COVID-19? Well, first of all, mitochondria, what's that? Most people don't think about mitochondria. A lot of people are. Some of my patients ask questions about mitochondria. So the best way to describe mitochondria is to talk about what it does. So this simple slide, and by the way, I've shared, there are a couple of articles I'm going to read through with you. So most of this presentation will be text pulled from a couple of articles. One is a review, the other is an editorial, and they go over some of the basics of what I'll be talking about. And you have in the link below, you have the links to digital links to both of these articles. The third article I'll discuss, you won't have a link to it, but you'll have the title in the slide, so you can be able to pull the information from the title. But anyway, function of the mitochondria. Mitochondria are important organelles of the cells. On all the organelles are important, but mitochondria are particularly important. I do recall reading and also hearing in some lectures that it's been proposed that mitochondria or like bacteria-like organisms that were overtaken by cells. Now, we know that our body lives in symbiosis of microbes. And so our microbiome, gut flora consists of bacteria, viruses, fungi, et cetera, and they live it's an ecosystem. So, this ecosystem probably existed, from our creation, and probably part of that, part of the ecosystem was, mitochondria, which are, bacteria-like organelles. And so they do a lot for the cells. But anyway, what are mitochondria? What do they do? Well, they produce ATP. Many of you may remember from your high school or college biology classes, these are the powerhouses of the cell. They produce ATP, adenosine triphosphate, and this is the energy currency. Any kind of cellular activity or chemical reactions that take place, often require ATP. Even the your cell membranes maintain a certain charge, and maintaining that charge of polarity, if you will, keeping, say, the negative charge on the inside and the positive charge on the outside, maintaining that differential polarity, which keeps the cell alive, requires energy. So that the energy currency that maintains, the polarity, because the natural tendency is for the charges to mix equally, but it has to maintain more negative on one side versus positive on the other side. And ATP is a constant energy expenditure that maintains that polarity. It helps regulate the immune system, which is going to be really, really important to what we're talking about today. Calcium balance is important. Also, cell death and renewal is important. So we have certain cells as a turnover. Body has to renew itself. And so it contributes to the process of, killing cells that are worn out and renewing cells. Also, stem cell regulation. These are brand new cells or undifferentiated cells, and they can be regulated because, if they, are not regulated, then you can have, development of cancer cells or the like, or over generation of cells, whether they're normal or abnormal. So mitochondria has an important role to play in terms of normal physiology, normal biological maintenance, energy maintenance, immunity, etc. And these top two are very important because these are very important roles that need to be played in overall health. So what can go wrong? The mitochondria, as we know, is a powerhouse, but it can also degenerate under pathological conditions. Dysfunctional mitochondria can become a death engine. So what can lead to the transition of the mitochondria from powerhouse to death engine? Well, excuse the business of the slide. I highlighted some of the key parts, but mitochondria is known as a powerhouse. It produces ATP. It also produces heat in specialized cells. These are brown fat cells. So in certain fat cells, it produces heat. And so that's on the beneficial side. There's intermediate metabolism. Mitochondria produces metabolites for biosynthesis, protein modification, signal transduction. This is just fancy jargon for it produces substances, metabolites. These are cellular components that allow for protein modification, which is the building process. Signal transduction, this is how the cells communicate with each other, and other forms of biosynthesis or biological development. In other words, this part of the machinery of what your body uses to manufacture things that the body needs. Also, it's part of the machinery to produce things that what your body needs to communicate with from cell to cell, tissue to tissue, organ to organ, etc. Now, oxidative phosphorylation, that's just a fancy phrase, means that when you breathe in oxygen, and many of you may remember studying the Krebs cycle when you were in maybe high school or college or whenever we first heard about the Krebs cycle. But all oxidative phosphorylation means is that oxygen goes into the cell and through a biochemical process leads to the production of ATP. In other words, it leads to attachment of a phosphorus molecule to adenosine diphosphate, making adenosine triphosphate or ATP, or phosphate to adenosine monophosphate, making a diphosphate, and putting another one, making a triphosphate. All that's fancy jargon for you breathe in, oxygen, and you get energy currency inside your cell. Taking a breath equals energy. That's oxidative phosphorylation. If you uncouple that, then you have to breathe in more, take in more oxygen to create a certain amount of ATP. So let's say, for instance, if your body's working very efficiently, maybe you take in one breath, and that one breath gives you, say, $100 worth of ATP. But let's say your body's not working efficiently, and you take in one breath. Instead of $100 worth of ATP, you only get $50 of ATP. Well, guess what? You got to get that $100 worth of ATP. So if there's a relative uncoupling, when I say uncoupling, there's a disconnect between the amount of oxygen you bring in and the amount of ATP you get, then you have to breathe harder, i.e. bring in more oxygen to get more ATP. And so you can imagine that if you're out of shape versus if you're in shape. So someone is very physiologically in shape and in good condition, have a very efficient oxidative phosphorylation, meaning that each breath gives you more ATP compared to if you're out of shape, each breath gives you less ATP, so you need to breathe harder. So that may be one little thing that I'm trying to help you understand oxidative phosphorylation from a real life perspective. So oxidative phosphorylation is coupled with generation of reactive oxygen species. What that means is these are toxins. Remember, we talked about reactive oxygen species before. You can also refer to them as free radicals. They have unpaired electrons. Essentially, just think of them as toxins. You need antioxidants to stabilize them. You need a certain number of these quote unquote toxins. Your immune system uses it to fight off, pathogens like bacteria and viruses, but you don't need too much of it. So you need a balance between these reactive oxygen species, i.e. toxins, and what we call antioxidants. That's why you eat a healthy diet. So it can either serve as molecular signals or cause cell damage or cell death. If it causes cell damage, cell death, again, your immune system can kill cells. We call them natural killer cells, and they have an important role. They need to have, these are like bullets. Think of these toxins like bullets. And so you need to create certain reactive oxygen species, i.e. toxins, i.e. bullets, so that you can kill cells. Cells may be pathogens, bacteria, viruses coming in, you shoot them down. Or it can be a cell that goes bad. You have your normal cells that weaken and deteriorate, and they need to be killed, like a horse with a broken leg. Got to shoot it. And so you have to shoot your cells sometimes if they're gone bad. What if a cell gets overtaken by a virus? Well, if the cell gets overtaken by a virus, i.e. COVID-19, that virus takes over the cell and forces that cell to make abnormal molecules, proteins, and it forces that cell to make more viruses. Well, guess what? That cell has become a traitor. What are you going to do? Need to kill the cell. So the reactive oxygen species can have a positive role, but if you have too many of them, then they can also start to float around and kill normal, healthy cells. And that's what leads to chronic illnesses. So excessive reactive oxygen species are toxic chemicals, are associated with increased what we call oxidative stress, which is associated with increased cell death and chronic illness. So I'm trying to put all this in perspective for you as we start to talk about what mitochondria does and so on. So mitochondrial metabolism stimulated by calcium. So calcium overload can trigger release of mitochondrial content such as cytochrome C. It induces apoptosis. Apoptosis just means cell death or loss of membrane potential, causing ATP deprivation and necrosis. So in other words, the mitochondrial membrane itself wears out. It cannot produce ATP or energy, and it starts to develop, starts to become necrotic and die. Because again, the cell membrane needs ATP, and if the cell membrane is not intact, then the mitochondria starts to die. And as the mitochondria dies, the cellular function becomes impaired, and you get cellular death or cellular dysfunction. And this can happen outside of any viral infection. It can happen by itself. And so we're going to talk about some things that impair mitochondrial function, as well as things that enhance mitochondrial function. So what we're talking about now is, well, okay, what happens when a mitochondria gets sick and start to die? these are the things that start to happen. You don't produce enough energy, then the cell itself becomes dysfunctional, and it can lead to cell death. Leakage of damage-associated materials, such as mitochondrial DNA, peptides, or excess reactive oxygen species, which is inside mitochondria, causes inflammation. This is probably a mechanism of heart failure and diabetes. So when the mitochondria dies, it leaks content, and these contents roam around in the cell, and it triggers inflammation, which leads to more intracellular damage. So the transition of the mitochondria from a powerhouse to a death engine is the key to pathogenesis and many chronic illnesses such as heart failure. So when the mitochondria dies, a healthy mitochondria is a powerhouse. It creates energy, and it does a lot of positive things for the cell. An unhealthy, dysfunctional mitochondria becomes a death cell that leads to cell dysfunction, low energy, and eventually cell death. That's what I want you to sell. Healthy mitochondria, powerhouse, more energy, healthy immune system, weak mitochondria, weak cell, less energy, and cell death. Here's a diagram that kind of outlines that. That helps make up for that ugly, busy slides that I had. But I want to give you some of the nuts and bolts. You can go back and look at it, the details later. So mitochondrial dysfunction, pathophysiology of heart failure. This could be any chronic illness, but on the functional side, as I said, ATP production, growth and adaptation. So protein modification, myocardial nuclear communication, mitochondria to nuclear communication. In other words, it's carrying on the business of cellular function. Biosynthesis and production of substances, creation of energy. Immune system is not put here, but in other cells, you can imagine it has immune functions like mitochondria within the endothelial cells of the lung, tissue of the gut. Gut lining cells would be a very important role for immune function, also in the heart as well. But calcium transport, so you start to have excess metabolic stimulation, excess stress, calcium homeostasis, reactive oxygen stress. If these things overflows, there's a balance you have to maintain. If it overflows into the dysfunctional side, then you get inflammation and increased cell death. And so that's what happens inside the mitochondria. And that leads to, if you have enough mitochondria that are dysfunctional within the cell, then you'll have essentially cellular death and, of course, impaired immune system. So I pulled a couple of articles where they looked at some of the detailed mechanisms. And this is the title. You have the link to this article where they looked at low cardiorespiratory and myocardial fitness as risk factors for viral infections with the implications for COVID-19. Essentially, and I apologize, this is a busy slide, but I just wanted to highlight some components in case some of you pull the article and go over it. So as we talked about, mitochondria are cellular powerhouses that generate the generators and regulators of metabolism and are critically involved in antiviral host response. They have on it that an important component is a mitochondrial antiviral signaling complex. So they have an antiviral signaling complex right on their membrane. It's on the outer part of the membrane, and this signaling complex gets activated by a family of pathogen-directing receptors. They're receptors that alert the mitochondria, alert the cell that, hey, viruses may be coming. This induces a response that includes certain molecules like interferons and the central to cellular defense. So the mitochondria gets alerted. There's an alert system. Somebody's on the lookout. Hey, there's viruses that communicate with the mitochondria. And the mitochondria start to create molecules like interferon that helps with cellular defense. Now, there's some viruses that evolve mechanisms to evade the signaling signal, and it can bypass that efficiency. But the point is simply this. They understand clearly how mitochondria, healthy mitochondria, play an important role in viral defense. And therefore, that's one direct mechanism of how mitochondria can help with the immune system. So what can cause, so we made the argument that mitochondria is important for cellular function and important for immune defense, particularly against viruses. So what causes mitochondrial dysfunction? Well, a lot of things can cause mitochondrial dysfunction. One thing we want to focus on here is the lack of exercise. So if you look at this diagram, which is from that other article, as you probably saw it earlier, regular exercise and regular fitness has a negative component on mitochondrial dysfunction. So in other words, exercise prevents mitochondrial dysfunction. It also prevents oxidative stress. It also decreases inflammation. But older age potentiates dysfunction of the mitochondria. It potentiates inflammation, and it potentiates oxidative stress, which all contribute to mitochondrial dysfunction, which all predispose to your risk of any viral infection, particularly COVID-19, but the flu or any kind of infection whatsoever. For mitochondrial dysfunction is important, and exercise is a simple way to do that. Here's another article where they looked at the central role of mitochondrial fitness in antiviral diseases. Essentially, on their analysis, they saw it enhance mitochondrial production function is enhanced by physical activity, including exercise, and an increase in integrity, efficiency, and dynamic adaptation to stresses. And in short, it leads to mitochondrial fitness. So basically, high mitochondrial fitness should be considered as protective factors in viral infections, including that of COVID-19. So whether it's the flu or any other viral infection, you want healthy mitochondria. This is a complex slide. Essentially, what I want to show you here in a diagrammatic format is how the mitochondria improves. So mitochondrial biogenesis means it replicates, you get more mitochondria. And there are certain supplements that you can take that improves mitochondrial function. Mitochondria can fuse them together to make larger mitochondria, improve effectiveness there. Mitochondria can signal cell death by releasing its content. We talked about that before. Its membrane becomes permeable, and some of the contents leak from the mitochondria inside. You could have inefficient mitochondria that gets destroyed. So death of the mitochondria is important. But you can also have fission of a healthy and an inefficient mitochondria, and it can be resuscitated by just fusing with a healthier mitochondria. So there are different ways that the mitochondria can improve its overall effect here. And here you see the diagram. This alert molecule function sends signal to the mitochondrial antiviral signaling complex, and it triggers a number of biochemical reactions that alerts the immune system, including production of ATP and other things that enhances immune function, such as production of reactive oxygen species that can be used to kill certain cells, viruses, or bacteria and the like. This is a nice simple diagram that goes into how different activity levels have an impact on mitochondrial health. So sitting sedentary like I'm doing right now, I'm decreasing my mitochondrial biogenesis and content. I could be decreasing my energy of oxphos and therefore ATP production, decrease in antioxidative defense mechanism, which is reactive oxygen species, can decrease in mitochondrial dynamics, meaning that decrease in efficiency in which mitochondria can fuse and improve dysfunctional mitochondria by the fission of a healthy mitochondria. And then quality control. So this mitochondria is dysfunctional. I'm not going to be efficient in terms of destroying poor quality mitochondria by sitting still. So poor quality control, that goes down. So what improves it? So chronic exercise improves all of these things at different tissue levels in the brain, muscle, lungs, this oxphos production, kidney, brain, lungs, liver, heart, muscle. So it shows how mitochondrial function improves all across the board in different tissues, skeletal muscles all across the board, brain and kidneys as related to antioxidative defense mechanisms, as well as the heart. And so these things improve significantly with chronic exercise and moderate intensity, so chronic and lifelong. If you look at acute chronic activity, all of these things are favorable with the exception of oxidative defense. So you have a decrease in antioxidative defense mechanism, And that might be a reason why you don't exercise in the setting of an acute viral infection. So you get a transient decrease in your antioxidant defense mechanism, which predisposes you to, say, maybe a worsening of an infection. So we often tell our patients not to exercise during the acute phase of a viral infection or bacterial infection or the like. So again, a bit of a technical discussion. I know, some people may not have grab that too much or try to break it down as much as possible. But I want you to really understand how the body works in the context of these disease states, but also in the context of health. It's not enough to say, oh, just exercise more. Well, okay, that's good, but what does it mean? How do I know that? I want to show you some evidence based on the science. Everyone's talking about follow the science, so we want to talk about the science. But I want to talk about from an evidence base. I want to just give you some, theory, say, okay, do this and it's healthy, but then the biology and the biochemistry don't match the recommendation. So if I say, oh, go exercise, get out fresh air and sunshine during the pandemic, and other experts are saying, no, stay in the house and hide, then I'm going to say, well, my recommendation is based on scientific evidence, based on the biology and the biochemical mechanisms. And that's important from the standpoint of saying, wait a minute, he's telling me to exercise. Why is he telling me that? And somebody else is telling me, well, stay in the house and hide. And which is best? Well, I'm going to say this is what my argument is based on: fresh air and sunshine, regular exercise. It has beneficial effects, not only from the standpoint of, well, I'm going to lose a few pounds or, build up some muscle, but it actually has biochemical and physiological effects. And we're showing you here at the cellular level how exercise enhances your body's immune system and enhances your ability to fight off a viral infection. So this is how it works. And this is what that information is based on. So, there's a little bit of technical discussion here, but I think there's an important aspect of it. And feel free to answer those questions in your chat as we get to the second half of this discussion. Now, part 2 of this presentation, what about the food? And so, the subtitle is Food and Fitness Factor. And exercise is important, but I also like to talk about food. And we discussed this article before. I'm just going to mention it briefly, a couple of slides on it. But this is and I didn't give you the references, but if you copy this title down and Google it, you'll be able to find the article if you haven't looked it up from our previous presentation. But plant-based diets, pescatarian diets, and COVID-19 severity, a population-based case control study in 6 countries. And this is an important thing, 6 countries. So what did they do? They got healthcare workers from 6 countries: France, Germany, Italy, Spain, the UK, and the USA, with substantial exposure to COVID-19 patients. Now, let me pause there. This is important because, there's a broad spectrum across, of individuals across 6 countries, and they are healthcare workers. So they have significant exposure. That's important. If I look at some studies, say, oh, well, we got, 1,000 people and looked at, what they did and this 1,000 had no effect. Well, if you don't know anything about that population, they may have been 1,000 people, hiding under a rock, and so, with no exposure to COVID. But these people are healthcare practitioners, so that puts them at high risk, high exposure. And they completed a web-based survey from July 17th to September 25th of 2020. They provided information on demographic characteristics, dietary information, COVID-19 outcomes. They looked at the association between self-reported diets and COVID-19 infection, severity, and duration. What did they find? What they found were participants who reported following plant-based diets and plant-based diets or pescatarian diets. So there were different groups. They said plant-based diets and another group plant-based or pescatarian. They had a 73% and 59% lower odds of moderate severe COVID-19 severity infection, respectively. So what does that mean? the plant-based, the individuals reported eating strictly a plant-based diet had a 73% decreased chance of developing moderate to severe COVID-19 infection. The group that said they eat either plant-based or pescatarians, in other words, they had some fish in there, they had a 59% reduction in moderate to severe COVID-19 infection. What about those who ate the keto diet? That's the low carbohydrate, high protein diet. Well, they had a greater odds ratio of moderate to severe COVID. How much greater? Was it 3.86? My goodness, that's almost 4 times. They had a 3.86 times increase. If you look at this odds ratio of 0.27, that's a 73% decrease. Odds ratio 0.49, 59% decrease. But odds ratio 3.86, that's greater than 1. This is all compared to 1, compared to people on just the standard, Western diet. Then they had a 3.86 times increase risk of getting moderate severe COVID-19 infection. So the more animal protein you ate, the more risk you had for severity of disease. Now, they didn't find any correlation with infection or hospitalization. So there was no difference in infection, etc. These were people with high exposure. So in 6 countries, plant-based diets or pescatarian diets were associated with lower odds of moderate severe COVID-19. Now, there's no survival data here, so I can't say that it saved lives, but if it decreased your chance of moderate severe COVID-19 infection, it's possible they had bigger numbers and did larger follow-ups and things like that. They might have been able to find that. I can't say that was shown, but it's really important to know because people are saying certain therapies are decreasing severity of infection. We know that one therapy has been shown in a very well done study where plant-based diet decreased infection. So the food and fitness factor, I think, is exercise and plant-based nutrition. We saw the mechanism with exercise in terms of you increasing mitochondrial function, therefore increasing ATP production, increasing immune function, and a plant-based diet helping out in terms of reducing severity of infection. And we've talked about the mechanism of plant-based diet, reducing oxidative stress, reducing cytokine formation, reducing inflammation. And by reducing inflammation, we talked about in the previous study, increased inflammation, increased triggering of the immune system. So your white blood counts a little bit on the high normal side and so on. It creates your immune system to cause your immune system to be on sort of high alert and cause a certain amount of dysregulation. And that dysregulation can lead to what we consider premature immunosenescence. Immunosenescence is sort of an impairment of the immune system that is associated with age and or chronic illness. So we have the mechanism of the food, we have the mechanism of exercise. So when Dr. Montgomery and Dr. Atkins say, hey, exercise and eat a healthy plant-based diet, this is what we're basing our information on. When you get other information, someone says, hide under your bed and put a mask on, what is the pathophysiology of enhancing your immune system? So that's something I want to share with you. What I'd like to do is take a quick break here, and I'll come back. I want to hear your comments. We're going to get Dr. Atkins' comments on this topic. I want to get your question and comments on the chat. Stay tuned. Okay, so we are back, and let me see what the comments, and Dr. Atkins is back to see as human beings, let's see here. Freedom as human beings, are we meant to move our bodies for optimal health and well-being? However, an average American sits for about 13 hours a day. Dr. Jockers, okay, that's a great comment there. So thanks for linking the articles. I will continue trying to reason with people regarding taking an all hands on deck instead of relying solely on the you know what. Okay, freedom. Yeah, that's exactly right. I think health is fundamental, and I think if we consider doing some of the basic things, it gets back to the basics. I think in terms of how you improve your health. Dr. Atkins, what are your thoughts on anything that was said before? This whole concept of nutrition and exercise or the like.
Well, first of all, I think you did a great presentation on that the process of producing energy, because again, it goes back to the foundation of it takes energy to make everything work. And I think where a lot of the problems we see when it comes to um, health is when that Krebs cycle or that oxidative chain is broken down and we can't produce the energy we need. So therefore, you can't produce the cells. Again, it directly affects immunity, and also it's going to affect our overall energy. I think one of the big problems is again is our toxic burden, or our toxic overload, when we introduce things in our body that will interfere with the mitochondria producing energy. And since they are the powerhouse of the small factories that produce the energy, adding things like monosodium glutamate, that's MSG, or adding other chemical additives, other preservatives, even things that are non-food items like Teflon, when we cook in Teflon cookware, or you microwaving in plastic, all of the plasticizers and things that come out, these things enter our system and they can interfere with that process. And so we think are becoming fatigued and tired because we're getting old. And I say, you're not getting old, you're just getting toxic. So that's one thing. That's why, because when you look at it, elderly people, they slow down not because of age all the time, it's because of toxicity. When you start seeing the oxidation of your skin and your wrinkle, when you start losing weight, irritability, stamina, our bone health, our cardiovascular health, all I always look at it as toxicity, because if you can maintain a level of cleanliness, then you do better. I think we talked about our bodies being functional. I think the first comment was great, because and then it made me start about thinking about who invented the chair, because sitting down is not really a function. Our arms, elbows, knees, feet are made for function and made for doing things. But when you sit, you don't really use any of those. So you want to spend more time being functional, because that way you bring in the oxygen and you have the fuel to make everything work.
Yeah, no, that's a great point. And, I'm glad you pointed out a lot of other things that has an adverse effect on mitochondrial function, because there are many things in our environment that has adverse, and many of the medications we take, these proton pump inhibitors can inhibit mitochondrial function. And one thing that individuals get recommend to take when they go in with COVID, they have fever, et cetera. They go to the emergency room and say, well, okay, you're not sick enough to come to the hospital, go home and take Tylenol. Well, Tylenol has an adverse effect on mitochondrial function. Yeah. I tell my patient, don't take Tylenol. Take, you get a liposome of curcumin, or some form of curcumin, some natural anti-inflammatory agent to help with pain and fever control, but not things like Tylenol. But again, we're so focused on pharmacological things, but these things work against our natural biology. Yes. And that's in part why oftentimes, well, not oftentimes, but that's in part why, or we can understand, I should say, why medications or medical treatment is the third leading cause for morbidity and mortality, because a lot of things we're doing to treat symptoms on the surface are having an adverse effect on our biological processes, such as mitochondrial function. Deborah Payne, how can we tell if a mitochondria needs attention or whether it's doing good? That's a great question. There's not there are not any specific tests to measure mitochondrial activity, other than the physiological things you can do. So you can do physiological tests that looks at your gas exchange with exercise, and there's a special test with a oxygen mask, and it looks at your cardiopulmonary status, so you can measure that. You also can look at blood tests that can look at coenzyme Q10 levels and other things. If you see a lot of Inflammation, that's a sign. Increased inflammation is an indirect sign of increased oxidative stress and poor mitochondrial function. And as I said, low coenzyme Q10 is probably a sign that there's a cofactor that enhances mitochondrial function. So that may be a sign that you need to improve coenzyme Q10 levels to improve mitochondrial function. And then probably other biochemical markers, but overall fitness, cardiopulmonary function, as well as some biochemical markers such as inflammation and the like, are some simple things that give you an indirect look at mitochondrial function. Anything you can add to that?
Yes, well, most people know the word stamina. So in general, when you just start off I guess for really a lay person, is your stamina. Can you walk a quarter of a mile? Can you walk an eighth of a mile? Can you walk up a flight of stairs and not be fatigued? You gave a good example opening the show when you talked about breathing. When you take one breath, or does it take you 3 breaths to do the same thing? Because if you don't have the stamina, then your mitochondria is not producing enough. So that's one thing that fitness and exercise is all about, is about building up stamina, but it's actually building up mitochondrial function, that they can produce enough ATP to where the muscles will work, where you're not fatigued, you can make it. And so if you feel you have poor stamina, or you can't keep up with your kids, or depending on age, because you're 40 or 50 doesn't mean you should be able to keep up with the kids.
That's right.
They're a little over the top, but still, they should fatigue you out. So that's a good sign.
Yeah, you probably should still outrun your kids at 40 or 50. I mean, if you unless they're like in athletics or something, they're training all the time and you're not. But other than that, you probably should be able to keep up with them. I agree. And again, that's a great question. So, the ways of understanding how the mitochondria works, and it's not necessarily a direct test, but there's some simple things, as Dr. Atkins said. Functional status is kind of a very simple way of saying, hey, my mitochondria is doing okay because I can run up these stairs with ease. And so I think these are things that, simple ways that we can look at how our body's functioning to enable us to understand, what's going on. And again, what you're doing to yourself also will contribute to that. So, if you're eating bad food and you take a lot of medications, that's a sign that you're doing harm to the mitochondria. If you're not getting out and working out on a regular basis, then you're not enhancing your mitochondrial fitness. And so, these are other ways of measuring how your mitochondria is doing, because you can measure what you're doing to the mitochondria. If you have a little baby and you hadn't fed it in 5 days, you don't have to measure a test to see what the baby smell, needs food. You haven't fed it in 5 days. When you say, well, I probably need to, instead of ordering some expensive test, go and feed the baby. So some of these things are very fundamental, very basic. But I think it's really important that we, pay attention to those simple things, because, I'll probably do a quick show either tonight or tomorrow on the recent CDC's warning of a real bad flu season. These guys are becoming like meteorologists. And so, they know something we don't know, but one thing we do know is that, in preparation of the ongoing flu season, there's some important things you need to do to improve your health. Improving your mitochondrial function is one of those things. So I think that's critical. Any other comments, Dr. Atkins, before we wrap it up? I think we've got all of the questions and comments addressed so far.
No, other than just to reiterate the fact that mitochondrial function, which is I guess a foundation of health and wellness when it comes to I guess nutrition and our life, is it's dependent. Everything's dependent upon it. So therefore, we want to make sure when it comes to these times when we need that extra immune function to produce the cells, the cells and all of the immune factors, that we want to do everything we can to maintain that optimal health and energy, because without that, again, you can't produce either cells or functioning cells that need to do their job. So I think it was a great presentation. I definitely am an advocate for people reading a little bit more detail and understanding how important that is. And again, we want to talk some more about some things we can do to improve mitochondria too. And we'll talk about that in a future episode.
Great, great. Well, thanks, Dr. Atkins. I appreciate contributing to this show and your always wonderful, insightful comments. And I will see you backstage as we close out. Um, well, thanks again for joining us tonight. And we hope that you got a lot out of this. If you haven't done so already, please hit the thumbs up button. And if you haven't subscribed, please subscribe and hit the notification button. And of course, if you really like this, please share this information with a loved one. What we try to do is empower you with knowledge to improve your own health. I'm not going to just say, okay, do this and do that. And of course, at the painstaking effort of discussing something as technically difficult as mitochondrial function. I know everybody's not, a science, guru or geek, but what we try to do is get you to understand to the best of our ability, get you to understand your bodies, how it works, how your body works, so that you take into what you're doing a level of understanding. I'm not going to say just, do this or don't do that. I'm going to try to connect the dots, help you connect the dots, meaning that this is how my body works. And by doing this, this creates this process by this mechanism. If I don't do this, this mechanism occurs. So again, mitochondrial function is very important. We're going to be talking about this more, as Dr. Atkins said. And so I hope you enjoyed this. Again, subscribe if you haven't, hit the notification button if you haven't. And of course, share and please like, and please share. We want to get this message out. Until next time, keep it fresh, natural, and live.